So in last class, we have seen the general types of gradients, right? Rising gradient, falling gradient that we are usually providing in a railway track, right? And apart from this general type of gradients like up gradient or down gradient, we have got four other types of gradients such as rolling gradient, pusher or helper gradient, momentum gradient, and gradients at station yards. Okay, so these are the four different types of or various gradients used on railway track. And among these gradients itself, you will be able to find the rising gradient and um, falling gradient. Okay, so let's see each gradient one by one. The first one being the rolling gradient. In fact, this rolling gradient is the steepest gradient which is allowed on the track section. So whenever or wherever you are taking a railway track section, if you are observing it, if they have provided any gradient, okay, any type of gradient, this rolling gradient is considered to be the steepest gradient. Or else you can simply say that in no case the gradient shall be greater than the ruling gradient. And in fact, this ruling gradient determines the maximum load that the locomotive can hold through a particular section. So depending upon the ruling gradient, if you have provided a ruling gradient and assume that that is a rising gradient, okay, rolling gradient can be either rising or falling depending upon നമ്മളൊരു ഏത് സൈഡിലേക്കാണോ പോകുന്നത്, depending upon that the ruling gradient can be either rising or falling gradient. ഒരു കയറ്റമാവാം അല്ലെങ്കിൽ ഇറക്കമാവാം. Assume that for time being you are climbing up, okay, ഒരു കയറ്റം കയറുകയാണ്, okay. So depending upon the ruling gradient, gradient simply means that the change in level, right? Upper up gradient, if you are climbing on a railway track section, depending upon the value of the gradient, the maximum load that your locomotive can carry also varies, right? നല്ലൊരു കയറ്റമാണെങ്കിൽ if it is too heavy, it will be very difficult for the locomotive to hold that section. And there is a maximum load corresponding to the value of the ruling gradient that that locomotive can handle also. അതുകൊണ്ടാണ് we are restricting the ruling gradient. Okay, there are some standard values that we will see in a couple of minutes. And if you're providing steep gradients, okay, on a particular track section, that means you need more powerful locomotives to carry these loads along that section. And it also means that you can carry only smaller train loads. If you are providing steeper gradients, you need more powerful locomotives to carry even smaller train loads. Again, the speed of your train will be less, okay? The train can pass through that section with lower speeds, and finally it results in costly haulage. The hauling cost will be very high because you need more powerful locomotives. Then also you will be able to carry smaller train loads with much lower speeds. So these are the results of steeper gradients. And for this reason, we are restricting the steepness of the ruling gradient. Okay. When it comes to plain regions or plain terrains, the ruling gradient in case of plain regions, the ruling gradient shall be between 1 in 150. Okay, so you are always expressing it either in terms of 1 by n or maybe x percentage likewise. So here they have expressed in 1 by n. For one horizontal 150 for one vertical 150 horizontal units. Okay, likewise. So in the case of plane regions, the ruling gradient you are providing for a track section should be between 1 in 150 to 1 in 200. Similarly, when it comes to hilly regions or hilly terrain, the ruling gradient shall be between 1 in 100 to 1 in 150. So these are the standard values that you can provide. Okay, the range of values. So you can provide a value which is between these ranges, just coming in between this range. Okay, so this is about ruling gradient. So now let's move to the next type of gradient, which is pusher gradient or helper gradient. So these types of pusher gradients or helper gradients are provided on railway track sections, especially in mountainous areas. Okay, when it comes to hilly regions, which is too much like high range areas, when you see so many mountainous terrain over there, in such cases you can go for this pusher or helper gradient because it is going to help you to reduce the length of the track. So if you are providing a normal gradient just like ruling gradient, then you need to provide more length for your track, or you need to haul greater distance in order to reach your destination. Okay, and another feature of this pusher gradient or helper gradient is that these gradients are steeper than the normal ruling gradients. Okay, these pusher gradient or helper gradients are much steeper than the normal ruling gradients. Okay, and hence in order to carry the same, or in order to haul the same load or the same train with the same load, you need to provide an extra engine so that the load can be carried or pulled up the hill, pulled up this gradient, pusher gradient. Okay, and since it needs an extra engine, because of this it is named as pusher gradient or helper gradient, because it needs the help of an extra engine to get hauled through that particular track section. And in India you can see this pusher gradient in Darjeeling Railways, and they have provided a value of 1 in 37. Okay, and it is provided on Western Ghats with a broad gauge track. Okay, so these are some of the facts about pusher gradient. So though in the previous slide we have discussed that the ruling gradient is the steepest gradient which is allowed on a track section, and in no case the gradients shall be greater than the ruling gradient, you should understand that there are some exceptions, because depending upon the terrain, if we are not considering the actual terrain and simply providing ruling gradient, then you won't be able to reach the destination uh, in an economical way. Okay, if you are instead of providing say 100-meter track, you may have to give 1 kilometer plus track length. Okay, which is going to increase the construction cost. And if the same thing can be achieved with much less cost and which is safer also, then we can go for this pusher gradient. But in the case of pusher gradient, you need to understand that in order to pull the same load, you need to provide an extra engine along with the normal engine. Okay. So that's about pusher gradient or helper gradient. And now coming to momentum gradient. So coming to momentum gradient. So if you have traveled in a train, you might have noticed that the gradients will be somewhat okay, small gradients. It won't be like that you are seeing on a highway. നല്ലൊരു കയറ്റം ഇറക്കമൊന്നും ഒരു ട്രെയിൻ ജേർണിയിൽ you might not have experienced because നമ്മളിപ്പോൾ ഇവിടുന്ന് എറണാകുളത്ത് നിന്ന് തൃശ്ശൂർ പോവുകയാണെങ്കിൽ there are gradients coming up, but we won't be able to feel it. Okay, because they are very sloped gradients. But still, if you are providing a okay, if you're providing a rising gradient, then this rising gradient will be followed by a falling gradient at some point. Okay, so there will be some track sections like that. A rising, you're trying to negotiate a rising section, okay, rising gradient, and soon after that a falling gradient is coming up, and maybe after this falling gradient another rising gradient is coming up. Okay, just assume that the alignment of your track section is in such a way that a rising section, then comes up a falling section, falling gradient, and another rising section. So when your train is climbing up this rising section, it need more power to climb this, right? When you're comparing it with a level ground, it need more power, right? And after climbing up this gradient, it is going down this valley, or it is going down this falling gradient. So at this point, when it reached the down point, it have acquired some extra power because it was climbing up the hill, right? And when this train is going down this falling gradient, it will acquire some extra momentum. Okay, momentum when it is going down the hill, or when it is moving down this falling gradient. Okay, and this happens only when a falling gradient is coming over a section soon after a rising section. അല്ല ഒരു ലെവൽ ഗ്രൗണ്ടിൽ നിന്ന് നേരെ താഴത്തേക്ക് പോകുമ്പോൾ അത്ര വരില്ല. Okay, so this happens only when this falling gradient is followed after your rising section. So when it is moving down this falling gradient, it will be acquiring some sufficient momentum or extra momentum. Okay, And this extra momentum gives your train an additional kinetic energy so that it will be able to climb up the next rising gradient even if it is more than your ruling gradient. Okay. So even if this rising gradient is steeper than your ruling gradient, your train will be able to climb up this rising gradient because of this extra kinetic energy which it had gained while it was traveling down this falling gradient. Okay. And this rising gradient, which is steeper than the ruling gradient, is known as your momentum gradient. Okay. And usually these different types of gradients, they are important. They are used to ask for uh, examinations. So as of now, we have seen ruling gradient, then pusher gradient. So it is very much steeper gradient, and you need an extra engine in order to climb up the hill. Then comes the momentum gradient. So in this case, you need different types of gradients. A rising gradient followed by a falling gradient, again, which is followed by a rising gradient. So here, this third gradient, okay, this third this third gradient or the second rising gradient, it will be pretty greater than the ruling gradient, and since it has acquired an additional kinetic energy while traveling down the falling gradient, it will be able to negotiate this rising gradient without any difficulty, and this rising gradient is known as momentum gradient. Okay, so move to the next type of gradient, which is known as the gradient at station yards. Okay. From the name itself, it is clear that these gradients are provided at the station yards. And why we are providing gradients at station yards? It is because of two reasons. The first reason is to prevent the movement of standing vehicle. So at station yards, the train will be halting there, right, to take the passengers for the loading unloading of goods and passengers. So in order to prevent the movement of standing vehicle, we are providing very less value of gradient over there. And second reason for providing a low value for this gradient is to prevent additional resistance due to gradient. So if you are providing a higher value of gradient, especially at station yards, when you are starting your vehicle or when your train is about to start, it will feel an additional resistance to overcome that gradient or to get moved. So in order to prevent that, we are providing a gradient which is having a lesser value at station yards. And why we are providing gradients at station yards? The main reason is to provide a good drainage. Okay, and for this reason, we are providing a minimum gradient of 1 in 1000, and the maximum gradient is limited to 1 in 400 at station yards. Okay, so these are the different types of ruling gradients apart from our falling and rising gradients. Okay, now next is grade compensation. So we have discussed grade compensation on curves in highways, right? Similarly, in railways also we have got grade compensation, and let's see how we are doing this grade compensation. Okay, and why, right? So if you have got a curve on your track section. And if you're providing a ruling gradient, if there is a level difference in this curve, then you need to provide a ruling gradient in this curve, right? So if you're providing a ruling gradient on your track section at this horizontal curve, then your track will be experiencing an extra resistance. And in order to avoid this resistance beyond the allowable limits, the gradients must be reduced on curves. So suppose if you are providing 1 in 250 gradient at this section, this will be the actual value of your ruling gradient. Okay, but since it is coming up on a curved section, you need to compensate it, or you need to reduce the value of the ruling gradient at this point. So you need to compensate it. Okay, and this reduction in the gradient is known as grade compensation for curves. And how you can reduce or how you can compensate the gradients? Again, some standard values are provided by the Indian Railways. If it is a broad gauge track, then the grade compensation shall be 0.04 percentage per degree of the curve. Similarly, if it is a meter gauge, the value should be 0.03 percentage per degree of the curve, and if it is a narrow gauge, the value is 0.02 percentage per degree of the curve. Okay, don't forget to write this percentage over here. It is not 4 percentage, but it is 0.04 percentage. Okay, some people used to get confused here, and they used to do the problem in a wrong manner. Okay, so let's start with a sample problem. All of you, please take down this question. If the ruling gradient is 1 in 150, if the ruling gradient is 1 in 150 on a particular section of broad gauge, and at the same time a curve of 4 degree is situated, a curve of 4 degree is situated on this rolling gradient. What should be the allowable rolling gradient? The question is very clear. You are given with the rolling gradient as 1 in 150 on a broad gauge track, right? So the track used is broad gauge. The gauge type is broad gauge. And at the same time, a curve of 4 degree is situated on the rolling gradient. So now you understand that there is a horizontal curve which is 4 degree, and you have provided a rolling gradient of 1 in 150, and the track is broad gauge. Okay, these three data are given. So these three are the given data, right? Now you need to find out what should be the allowable rolling gradient. So you need to find out the compensation for this horizontal curve, and you need to apply the compensation to find out the allowable rolling gradient, right? So as per the Indian Railways, you know that the grade compensation, the grade compensation for broad gauge is 0.04 percentage per degree of the curve.
മാം പ്രസന്റേഷൻ സ്റ്റോപ്പ് ചെയ്തതാ?
Allah, I'm presenting it.
മാം
You
സ്റ്റോപ്പ്
can.
ആയി പോയി.
നിങ്ങൾക്ക് ഏതെങ്കിലും സ്ലൈഡ് കാണാനുണ്ടോ? ഒന്നും കാണുന്നില്ല. അയ്യോ. Am I audible?
ആ മിസ് കേൾക്കുന്നുണ്ട്, പക്ഷെ കാണുന്നില്ല.
Okay. Can you see right now?
ആ മിസ് ഓക്കെ.
The question is visible, right?
യെസ് മാം.
Okay. Ah. So these are the different data which is given to you in the question. So this is the ruling gradient, this is the track detail, then this is the curve, degree of the curve. Okay, so that is the horizontal curve. So these three are the given data. And as per the Indian Railway standard, they have stated that the grade compensation for a broad gauge track is 0.04 percentage per degree of the curve. So you need to write grade compensation, okay? Grade compensation for broad gauge is equal to this thing. And what is a given ruling gradient? It is 1 in 150. And find out what is 1 in 150 in percentage. What is the answer? Can I have the answer, please? What is 1 in 150? Shina.
Miss
Ah,
1 in 150 എന്ന് പറയുമ്പോൾ 1/150 0.66
0 point
66%.
0.666 എന്ന് പോകുന്നില്ലേ അല്ലേ?
അത് പോണ്ട്.
Recurring. Recurring. So it is 0.67%. Okay. Now you need to find out what should be the grade compensation for a broad gauge. In our case, the degree of the curve is 4 degree. So here you need to find out, okay, below this you need to find out 4 percentage is there into 4 degree. What is that? 0.16 percentage, right? Now you will be able to find out the maximum allowable ruling gradient for this stretch. You can just deduct the grade compensation from our ruling gradient. What is the answer? Arundhati. Arundhati undo?
Miss
ആ
Miss
ആ യെസ് പറഞ്ഞോളൂ.
0.506 കേക്ക്. ഹലോ മിസ്,
ആ യെസ്.
കേക്കണില്ലേ? 0.506.
ആ യെസ്. അയ്യോ. So the answer is 0.506. Instead of 506, you can write 0.51 percentage. Okay. So this is the maximum allowable ruling gradient in this case. Okay. Now you can take down another question. What should be the second question? Okay. What should be the actual ruling gradient? Then two sub questions are the first sub question. If the ruling gradient is 1 in 200 on a broad gauge. And second sub question, a curve of 3 degree is superimposed on the above track section of broad gauge. Okay. So here you have the ruling gradient is 1 in 200. The gauge is broad gauge and you are given with a curve of 3 degree. Okay. So ruling gradient is 1 in 200 and in percentage, find out what is the value. Then grade compensation for broad gauge track 0.04 percentage per degree of the curve. Here the degree of the curve is 3 degree. So you can find out that also here. Okay. Now you need to find out the actual ruling gradient. So actual ruling gradient will be the given ruling gradient minus grade compensation. Asmiya, what is ruling gradient? 1 in 200?
Hello, Miss.
Ah, yes. Answer പറയൂ. 1 in 200.
Miss 0.5.
0.5 percentage. And what about grade compensation? Asmiya?
0.12.
Ah, 0.12. So now you can deduct 0.12 from 0.5 to get your actual ruling gradient, which is nothing but എത്രയാ?
0.38.
Yeah, 0.38 percentage. Now, along with this type of representation, okay, when you are getting this answer, it is correct, okay, but along with this, you can express it in terms of 1 in n. ഈ ഒരു ഫോമിലേക്ക് റെപ്രസെന്റ് ചെയ്യാം. അപ്പം നമ്മൾ ഇവിടുന്ന് കൺവേർട്ട് ചെയ്തില്ലേ 1 in 200നെ നമ്മൾ വി ഹാവ് കൺവേർട്ടഡ് ഇറ്റ് ഇൻ ടു പെർസെൻറ്റേജ്. സിമിലർലി യു ക്യാൻ കൺവേർട്ട് ഇറ്റ് ബാക്ക്. സോ വാട്ട് ഈസ് 0.38 percentage? 1 in which is equal to 1 in കിട്ടിയോ അസ്മിയ?
എന്നോടാണോ?
അതെ.
ഒരു മിനിറ്റ്.
Anybody else got?
മിസ് 2.6 ആണോ? അല്ലേ?
2.6 ആയിട്ടുണ്ട്. Okay, so this is 0.38 percentage അല്ലേ? Which means it is 0.38 divided by 100. ഇതിനെ നമുക്ക് 1 in ടേംസിൽ 1 in n ടേംസിൽ റെപ്രസെന്റ് ചെയ്യണമെങ്കിൽ യു നീഡ് ടു റീറൈറ്റ് ദിസ് ആസ്, ഇത് രണ്ടും സെയിം അല്ലേ? Okay, now take 100 by 0.38. So you'll be getting 1 in 264. ഞാൻ എന്തുകൊണ്ടാണ് ഇങ്ങനെ എക്സ്പ്രസ് ചെയ്യാൻ പറഞ്ഞതെന്ന് വെച്ച് കഴിഞ്ഞാൽ in answer key or answer scheme for university examination, okay, in major cases I have seen that they are giving the gradients in terms of 1 in n. ഈ 1 in n എന്നുള്ള ഫോമിലാണ് they are giving, because in the question also they have mentioned like that, അല്ലേ? So the answer is also they are giving like this. So why we should take a chance? So what you have written over here is correct. 0.38% is correct. And if you are finishing your answer with this, the one who is evaluating your answer script should give you full marks provided you have write down every steps, okay, all these standard things, substituted the values, everything, then you should get full marks for this problem. But whenever some revaluation sort of things are coming up, I have seen that some of the students have lost mark for these things, or not writing the standard values, or not writing the final answer in the appropriate form. Okay, so in order to avoid those things, after getting the answer in percentage, you can convert it back into 1 in n form. Okay, so if you are expressing your gradient in 1 in n or x percentage, both are right, but still. Okay. Now there are two more problems. You can just take it down and solve by yourself. So the difference is one is meter gauge and one is narrow gauge. Okay. So in the first question, if the ruling gradient is 1 in 150 on a particular section of meter gauge, and at the same time, a curve of 4 degrees is situated on this ruling gradient, what should be the allowable ruling gradient? The second question is, what should be the actual ruling gradient if the ruling gradient is 1 in 200 on a narrow gauge and a curve of 3 degrees is superimposed on it? നമ്മൾ നേരത്തെ ചെയ്ത സെയിം പ്രോബ്ലംസ് ആണ്. അതിൽ ചേഞ്ച് വരുത്തിയത് രണ്ടും ബ്രോഡ് ഗേജ് ആയിരുന്നു. ഇൻ ദിസ് കേസ് വൺ ഈസ് മീറ്റർ ഗേജ് ആൻഡ് ദ അതർ തിങ് ഈസ് നാരോ ഗേജ്. ഓക്കെ.